Hi, my name is Chong Wei from Faculty of Mechanical Engineering and Technology, University Malaysia Police. Today, I want to share about my project with the title of From Rice Husk to Silica, a Sustainable Transformation. Introduction for this project is large quantity of the rice husk in Malaysia need to proper disposal to avoid environmental issue. Advancement in silica extraction from the rice husk help to sustainable material science. So from the right side figure here, we can see that silica contain large portion of the chemical composition in the rice husk. So this is the reason why we choose rice husk as our raw material. So what is rice husk? Rice husk basically is a byproduct of rice milling. It is rich sources of atmosphere silica suitable for silicon production. The problem statement for this project is in the electrochemical transformation of the rice husk silica to silicon, there are a lot of impurities. Continuous operation leads to impurity build-up in the electrolysis path, require pre-electrolysis. The second one will be the efficient eliminations of the impurities in the rice husk through citric acid leaching need exploration to enhance the reductions process efficiency. The simplifies of this process will be the waste product plus the organic acid. Next, the objective for this project is to demonstrate the ability to produce high purity silica derived from rice husk based on the technique developed at lab scale. In this project, there are three feedstock that will be used. The first one will be the raw rice husk, which direct source from the local rice mill. The second one is the black rice husk ash collected from the local rice mill industry. And then the last one will be the white rice husk ash, which we prepare in the lab. Next, this is the flow chart for the leaching treatment and silica production. The silica production start up with the rice husk dried in an oven, then using a mechanical grinder and ball mill to grind the rice husk into powder form. After that, it will go through the leaching process. After the leaching process, the sample will dry in an oven to remove the extra moisture. Lastly, the sample will undergo the sintering process and silica can be produced. Next to the result and finding part. So this is the summary of input rice husk to output silica table. There are three different feedstock. For raw rice husk, we able to obtain 4 gram of the silica from 25 gram of feedstock. For black rice husk ash is 70 gram, and for white rice husk ash is the highest, which is 24 gram. This table summarizes the differences in properties between the raw rice husk, black rice husk ash, and white rice husk ash, and how their respective physical form transition through the processes of silica production. It is clearly shown that it becomes finer when undergo combustion process. The color of three feedstock has also significant changes. Next, the chemical composition of rice husk based on the X-ray fluorescence analysis. From this analysis, it can be clearly shown that the percentage of the silica increase after leaching process while the percentage of iron impurity decrease. To investigate the structural phase of the silica octane, X-ray diffraction analysis was conducted on both raw rice husk, black rice husk ash, and white rice husk ash sample. Both of the rice husk ash and raw rice husk in atmosphere phase due to the presence of halo peak, while for white rice husk ash, it is in crystalline phase because it exhibits distinct peak. The microstructure of the raw rice husk before and after the acid leaching process is depicted using the scanning electron microscope (SEM). The sample were initially ground using a ball mill, revealing a substantial increase in exposed surface area. The citric acid leaching induces the fermentation of the raw rice husk into smaller particles. Hence, the greater the surface area, the higher the chance of collisions, thus the faster the rate of reaction. The novelty and advantage for this project is the citric acid with low concentration proves significant extraction of silica. It can minimum the effect on environment and processing. The advantage will be the transforming the agricultural waste to useful material. This project also align with the SDG 9, 12, and 13. In this project, we collab with the one of the local industry, which is the composite technology Wood Senya Berhad in Gurun Kedah, in which they support us the feedstock. Our project also granted by the Foreign, Commonwealth and Development Office, UK. So the conclusion for the project is optimum feedstock and high yield. Complete combustion of the rice husk ash, which is the white rice husk ash, achieved the highest silica yield, 96% compared to the black rice husk ash, 68%, and the raw rice husk, which only 16%. White rice husk ash, higher weight to feedstock ratio, around 20%, ensure the production efficiency with the significant advantage in logistic and cost management. That's all for this project. Thank you for your attention.